Picture this. You've just started your first year as a tech student. Maybe you're doing a BTech, BCA, or a computer science program. You sit down, you feel this massive spark of excitement, and then you open Instagram or LinkedIn. Suddenly, everyone else is a genius, right? You see a peer building some crazy complex AI app. Another one is diving headfirst into web development. Someone else just posted that they literally solved their 500th LeetCode code question and they're already talking about placements. The excitement totally vanishes and you're just hit with this massive wave of panic. And you ask yourself, am I already behind? Well, take a deep breath because you really aren't. The absolute biggest mistake first-year students make in this hyper-competitive environment is trying to learn every single thing all at once. They jump from C to Python to Java to web dev to AI, and then they hear a whisper about cybersecurity and pivot all over again. After 6 months of this frantic sprinting, sure, they know the names of 10 different technologies, but they can't build a single proper project. It's entirely an illusion of progress. So, welcome to today's Explainer. We're going to break down the ultimate, absolutely no-nonsense roadmap for your first year as a tech student in 2026. This is specifically designed to help you stop chasing all that hype, tune out the social media noise, and actually start building an unshakable foundation that will serve your career for years to come. Here's our step-by-step map to cure that tech anxiety. We're going to cover the actual first-year goal, how to tackle months 1 and 2 with fundamentals, moving into small projects in months 3 and 4, building real projects in months 5 and 6, and we'll wrap it all up with modern developer tools. Section 1. The first-year goal, setting the right expectations. Let's just immediately throw out this idea that your first year is supposed to turn you into a senior software engineer. Your real focus should honestly just be on these 4 pillars. First up, strong programming fundamentals. That means being comfortable actually writing code yourself, not just mindlessly copying it from a video. Second, finding one strong technical direction to explore. Whether that's front-end, back-end, data science, or cloud, you just need to figure out what you actually enjoy doing. Third is establishing proof of work. This means having a GitHub profile containing actual code you've written, instead of just waving around some generic completion certificate. By the end of the year, you want to be able to say, hey, I built this, not I watched 100 hours of tutorials. And fourth, good habits. Things like coding daily, using Git, and reading documentation. Trust me, your future self will absolutely thank you for this one. Now, when it comes to picking your very first programming language, you don't need 5. You really only need 1. If you want to heavily focus on data structures and algorithms or competitive programming, C++ gives you blazing fast execution and a massive community for interview prep. If you're leaning more toward back-end and enterprise software, Java is fantastic because it teaches object-oriented programming incredibly well. And if you're strongly interested in AI or data, Python is your obvious starting line. But remember the golden rule here. Use your first language to learn core programming concepts. The language itself honestly doesn't matter nearly as much as the underlying logic you build with it. Moving on to Section 2, Month 1 and 2, Fundamentals, Master the Basics. Here is what your first 60 days should look like. No React, no Kubernetes, no TensorFlow, just the absolute basics. Please, whatever you do, don't spend 3 months mindlessly watching tutorials just to feel productive. Instead, use this highly effective learning cycle. Step 1, learn a fundamental concept, like loops or arrays. Step 2, solve 10 to 20 basic problems involving that specific concept. Step 3, build a tiny, simple program using what you just learned. And then step 4, repeat. You really want to avoid tutorial hell because, let's be real, you don't actually understand a concept until you can use it without a video holding your hand. Around this time, you'll inevitably start hearing that data structures and algorithms, or DSA, is absolutely crucial for placements. But don't immediately start grinding out hard-level LeetCode questions. 30 to 60 minutes a day is plenty. Your goal right now is building your problem-solving ability, not just hitting some arbitrary number like 500 problems. Try solving just 5 to 7 problems a week. Understand the problem, think about the brute force method, try to improve it, code it, test it, and only then, at the very end, should you look at the solution. That's how you actually wire your brain to solve problems. So the really crucial point here is balance. It's so easy to get totally swept up in coding that you completely ignore your college academics until right before exams, and then panic sets in. You don't need to study college subjects like digital logic or physics all day long, but definitely don't let your GPA collapse either. Dedicate 1 to 2 hours a day to your coursework, because college academics are your baseline, while these new tech skills you're learning are what will actually fuel your long-term career. You genuinely need both to succeed.
Section 3, Months 3 and 4, Small Projects Start Development.
This is a super exciting phase because your learning finally becomes visible work. You should really follow this steady 3-project progression rather than ending up with a GitHub filled with 20 random files copied straight from YouTube. Start small in month 3 with a beginner project. Think along the lines of a to-do app, a weather app, or a simple expense tracker. Then in month 4, bump it up to an intermediate project using APIs, databases, or authentication, maybe a movie discovery app or a basic blog. These projects teach you what tutorials hide: real-world debugging, managing file structures, handling state, and figuring out how to deal with errors totally on your own. Section 4, Months 5 and 6, Real Projects. Combine your skills. This is the culmination of your entire first year, where you combine everything you've learned to build your signature project. And what's fascinating here is just how much value is packed into a single well-executed idea. Let's say you build a student job tracker where users can create accounts, add companies, and track their interview rounds. Building and deploying just this one robust application is going to force you to learn authentication, database management, API design, and deployment platforms like Vercel or Netlify. This one proper project teaches you infinitely more than 20 surface-level tutorial projects ever could. Plus, it proves to anyone looking that you actually know how to build real software.
Section 5, Modern Developer Tools, the Essentials.
Throughout this whole timeline, there are a few foundational side skills you absolutely must pick up. These are the secret weapons that separate you from the absolute beginners. First off, Git and GitHub. Your profile shouldn't just be a graveyard of empty repositories with commit messages that just say fixed stuff. Make it clean with a proper commit history and screenshots. Next up, learn how the internet actually works. You should know what happens behind the scenes when you type a web address into your browser, what an IP, DNS, or HTTP request really is. Third, pick up some basic SQL. You're eventually going to need to store real data. And lastly, build the habit of reading official documentation. Real developers don't memorize everything. They know how to search, read the docs, test things out, and implement them. And since this is an explainer for 2026, we have to talk about the elephant in the room, AI. You absolutely should learn how to use AI, but you really need to recognize the massive difference between using it and depending on it. Use AI as a personalized tutor to explain tough concepts, generate test cases, or brainstorm ideas. But never, ever get into the habit of copying a problem, pasting it into the AI, and just submitting the answer. Because eventually you'll be sitting in an interview, they'll point to your project and ask, hey, why did you use this approach? And if you used AI as a crutch, you'll have absolutely no answer. Use it to make yourself stronger, not weaker. So, as we wrap up this roadmap today, I want to leave you with this final critical thought. The tech world is always going to be loud, and there will literally always be a new, flashy tool trying to distract you. So will you let social media panic dictate your studies, bouncing from one hyped framework to the next, mastering absolutely none of them? Or will you follow this focused roadmap to block out the noise and build a developer foundation that actually lasts? The choice of how you spend your next 12 months is entirely up to you. Get out there, start with the basics, and start building.